Welcome back to section 2.5. What we're going to be doing is finding all the zeros given that 1 plus 3i is a zero. If you remember the conjugate rule, 1 minus 3i must also be a zero. Now, what we have to do is we have to figure out what an actual factor would be. And to do that, we're going to find out what the polynomial would be where they have zeros of 1 minus 3i and 1 plus 3i. So x minus the quantity of 1 plus 3i is a factor. X minus the quantity of 1 minus 3i is a factor. So we get x minus 1 minus 3i, x minus 1 plus 3i. So I'm going to use that method where I group together the x minus 1. So it's going to be x minus 1 squared minus, and then we square the 3i's. When I square x minus 1, I get x squared minus 2x plus 1 minus, and when I square the 3i, I get 9i squared. And negative 9i squared is equal to a positive 9. So it's x squared minus 2x plus 10. Now, because that is one of my factors, and it's a trinomial, I can't use synthetic division, unfortunately. I have to use long division. So on the outside, x squared minus 2x plus 10. And on the inside, x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. No placeholders needed. Once again, with long division, I only care about the first terms. X squared to x to the fourth, I'm going to multiply by an x squared. I went over 3 places because it's a trinomial and my x squareds are all lined up. So I distribute, I get x to the fourth minus 2x cubed plus 10x squared. I'm subtracting the polynomial, so I distribute my negative. Change all of the signs. When I add, they cancel. We get a negative x cubed minus 4x squared, and then bring down the plus 2x. Once again, I only care about the first terms, x squared to an x cubed. I multiply by a negative x. I get negative x cubed plus 2x squared minus 10x. We're subtracting the whole thing, so distribute the negative. Change all the signs. They cancel. Negative 6x squared plus 12x, and then bring down the negative 60. Now to get x squared to be a negative 6x squared, I have a negative 6. Distribute negative 6x squared plus 12x minus 60, and don't forget we're subtracting the entire thing. Distribute the negative, change all of the signs. They cancel, cancel, cancel. Remainder of 0 is good. We know that that is absolutely one of our factors. So if we're looking to factor this, f of x equals, so far, x squared minus 2x plus 10. And the remaining factor is x squared minus x minus 6. So f of x equals x squared minus 2x plus 10. We can't factor that nicely. But the other factors, x squared minus x minus 6, is just x minus 3 and x plus 2. So our zeros, when we set them equal to 0, we knew that from the beginning that was x equals 1 plus 3i, 1 minus 3i, and then for other ones, x equals 3 and x equals negative 2. There's our 4 zeros. Let's go to the next page and problem number 11. So now we're going to find the zeros of this. We're given that 2 minus I is a 0. So if 2 minus I is a 0, 2 plus I is a 0. So we're going to find the factors. X minus the quantity of 2 minus I. x minus the quantity of 2 plus I. X minus 2 plus I, x minus 2 minus I. So once again, I'm going to multiply grouping. I'm going to square the x minus 2, and I'm going to square the I. So it's going to be x squared minus 4x plus 4 minus I squared. And that negative I squared is equal to a positive 1. So I get x squared minus 4x plus 5. And you can see once you get used to it, it's a lot quicker to multiply that way. Back to our long division. X squared minus 4x plus 5 goes on the outside. And on the inside, x cubed minus 7x squared plus 17x minus 15. X squared to an x cubed, we're going to multiply by an x. Went over 3 places, you can see the x's are lined up. Distribute, we get x cubed minus 4x squared plus 5x. We're subtracting, so distribute the negative, change every single sign. Cancel. Negative 3x squared plus 12x minus 15. X squared to become a negative 3x squared multiplied by a negative 3. Negative 3x squared plus 12x minus 15. Add the two polynomials, change all the signs. Subtracting, so change all the signs, distribute that negative, and we get a remainder of 0. So our factors, x squared minus 4x plus 5, and then the remaining was x minus 3. So from this, in the beginning, we knew that x equals 2 minus I, x equals 2 plus I, and then x equals 3 as our final 0. And there we go. Now for number 12. We're going to write this as a product of its linear factors. Now, we're going to factor this whole thing. We have our possibles. We don't have a whole lot of information given here. So for the possibles, we have plus or minus for the factors of 8. 1, 2, 4, and 8. And plus or minus 1 for the leading coefficient. So our possibles are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. I don't feel like trying those all out. So I can look at the graph, and from the graph, I can see that x equals 1 and x equals negative 2. Those are intercepts, and it doesn't matter which one I use first. I'm going to use the 1, and because I can do this, our factors would be x minus 1 and x minus negative 2, which is x plus 2 are our factors. They're binomials of degree 1. So I can use my synthetic division here. So I'm going to put my 1 on the outside. On the inside, 1, 0 for the x to the 4th, 1, 2, negative 12, and 8. Bring down the 1, 1, 1, 1, 2, 2, 4, 4, negative 8, remainder of 0. Good. So that was our coefficient for x to the 5th. So this is our coefficient for x to the 4th. So our factors so far, f of x equals x minus 1, and then x to the 4th plus x cubed plus 2x squared plus 4x minus 8. And now we're going to use the negative 2 and keep working through this. So from above, bring down the 1, the 2, the 4, and the negative 8. Our smaller polynomial, not the original. Bring down the 1, negative 2, negative 1, positive 2. We get a 4. Negative 2 times 4 is negative 8. We get a negative 4. We get a positive 8, and a remainder of 0. That's good. So f of x equals, we have our factors. We have the x minus 1. Now we have the x plus 2. And next, we have the x cubed minus x squared plus 4x minus 4. I can factor this cubic by grouping. So off to the side here, x cubed minus x squared plus 4x minus 4. I don't have any other zeros. I can't use synthetic anymore. So for the first two terms, I can factor out an x squared. So x squared times x minus 1. Last two terms, I can factor out a 4x minus 1. So it's x minus 1 times x squared plus 4. So I get x minus 1, x plus 2, x minus 1 again, and then x squared plus 4. Now it said find the zeros and the linear factors. That's a quadratic factor, not a linear factor. So what I can do is I can solve x squared plus 4, set it equal to 0. X squared equals negative 4, so x equals, when we take the square root of both sides, plus or minus 2i. So my factors, f of x minus 1 and x minus 1, that's x minus 1 squared, x plus 2, and for these zeros, it's going to be x minus 2i, x minus negative 2i. So it's going to be x minus 1 squared, x plus 2, x minus 2i, x plus 2i. Those are the linear factors. And now the zeros, x equals 1, that's repeated. It's got a multiplicity of 2, and you'll see on the graph it actually bounces there. We have a negative 2, we have a 2i, and a negative 2i. There's our 5 zeros. And it's 5 zeros because the 1 is repeated twice. We count it twice. A little tricky. We'll be seeing these examples as well more often, so we'll see it. Problem number 13. We're going to write this as a product of its linear factors. So now I can see 0 equals x squared plus 64. So x squared equals negative 64. I can take the square root of both sides, so x equals plus or minus 8i. There's our zeros. So the linear factors, f of x equals, remember, we're just subtracting the zeros from x. X minus 8i, x minus negative 8i. So it's x minus 8i and x plus 8i. Those are the linear factors for that. Now another one. I can't factor this. And because I see a nice even number for our middle term, I'm going to use completing the square. We could use quadratic formula. We're going to get the same exact answer. So 0 equals x squared minus 4x plus 1. I'm going to subtract 1 from both sides. Negative 1, leave some space, equals x squared minus 4x. And I'm leaving that space because I'm going to be adding the negative 4 divided by 2 squared to both sides. So I get negative 1 plus 4 equals x squared minus 4x plus 4. 3 equals, and when I factor, I get the quantity of x minus 2 squared. Take the square root of both sides, so you get plus or minus the square root of 3 equals x minus 2. Add 2 to both sides, so x equals 2 plus or minus the square root of 3. There's my zeros. So for my factors, my linear factors, f of x equals. So it's x minus 2, the quantity of 2 plus the square root of 3. X minus the quantity of 2 minus the square root of 3. So our factors, f of x equals x minus 2 minus the square root of 3, x minus 2 plus the square root of 3. There's our linear factors. That's what it would look like with linear factors. Okay. That is it for section 2.5. I will see you in section 2.6 to finish chapter 2. Thank you.